Diode. The longer end right here is the positive end, and that's called the anode. The shorter end is the cathode. Diode in a circuit diagram looks something like this, with this end being the anode and that end being the cathode. In a circuit, the current must come through the anode, but it cannot flow through the cathode. Used in a variety of circuits to rectify an input signal or change its input signal. For example, in these two configuration circuit diagrams, they have an input signal and diodes configured in a certain orientation to affect the input or output signal. For instance, in part A, in the top circuit diagram, the input signal would be a traditional ordinary sine wave, but the output signal would actually have the same positive peak value, but it would be minus 0.7 from the input sinusoid. Likewise, the bottom portion would be entirely clipped because you have the first diode cutting off signal and the second diode clipping it and staying stationary, so the output sinusoid would be just an ordinary sinusoid, and the zero and the output signal would be 0 volts. When solving problems using diodes, that we have to determine whether or not the diode is in forward bias or reverse bias. If it's in forward bias, that means the diode is on and that it creates a short circuit. Likewise, if it's in reverse bias, that means the diode is off and it creates an open circuit. To do this, we must make an assumption. If we assume in this case the diode is on, we will go through this problem and solve and see whether or not our current is positive. If it is indeed positive, then we have verified our assumption and we can assume that in this case the diode is on. Otherwise, the diode is off and it creates a short circuit. But it's always important to verify your assumptions that you make to determine whether or not the diode is on or off.